All right, we're going to take a look here now at example number 2. This is technically one that during class, if we had class right now, I would ask you to go ahead and try to start taking a look at these questions. So I'm actually going to ask you the same thing right now. I'm going to ask you to pause this video and try to work through these examples on your own before you take a look at my justification and my walkthrough. I'm going to go through my walkthrough fairly quickly, assuming that you've already spent some time thinking about it. So pause the video right now. Give yourself an opportunity to struggle through these. Even if you have no idea necessarily if your answer is perfectly correct, give it a shot, because experience is something you need to start building with these ideas. Okay, I'm going to go ahead and take a look here at each of these and show you how I would have worked through them. So here's what I have at the start. If I'm going to work with this comparison test here, I'm going to have to go ahead and start by making a comparison. I can see that up above I don't have something that's nice and easy to work with here in part A. So I'm going to go ahead and do the following. I'll say this. We see that 1 over 2n squared plus n. I could make that a bit simpler, maybe if I got rid of the plus n. What I'll notice now is this looks more like a p-series, and maybe if this thing converges or diverges, things will be great. I need to figure out though which way the inequality symbol goes, and it should go this way because the fraction on the left has more stuff in the denominator, which should make it smaller. So this is true for all n greater than or equal to 1. I can also say that we note that the series starting from 1 over 2 to the n squared, I can take that 1/2 and pull it out. And so these things then contains a p-series. So I'll say this guy is a p-series with p equal to 2, which is greater than 1. And so it converges. So the series 1 over 2n squared also converges. Okay, great. So I kind of see right now that this bigger addition problem is going to be convergent. Got to check my conditions though. Both series contain only non-negative terms. Notice here when I talk about both series, I'm referring to this one and the original. And therefore I can reach a conclusion. So I'll say therefore, by the comparison test, the series 1 over 2n squared plus n converges. It's trapped below a convergent series, and so it must also converge. Okay, I'm going to try to go ahead and take a look at part B and see if I can try to do something similar. Okay, all right. Ooh, I don't have much space for part B, so I guess I will just try to squeeze it in here. Let's see what we got. Okay, I'll start by saying we see that the arctan of n over n to the 1.8, I think I could claim the following. Based on the picture of the arctangent function, I can claim that the arctangent, no matter what I have plugged in for n, will never exceed pi over 2. Remember, that's a horizontal asymptote. So I could make this work. Now, again, I'm making this look really easy. You might have tried several different things that maybe ended up failing or didn't work. again, it's just that I have to continually try to push towards something that allows me to have something over here that I do understand as a good series, that I know something about. Like here again, I can see a p-series shaping up, but I also kind of want my inequality symbol to face in a convenient direction. So let's see. We see that if I have this for n greater than or equal to 1, and I can see that this is a p-series with p equaling 1.8, which is greater than 1. And thus converges. Both series, again, obviously contain only non-negative terms. So by the comparison test, the series that we are working with must converge. Okay. Again, I think comparison tests can be probably one of the more complicated tests that we have to work with because it requires a lot of experimentation. Whenever you read my solutions or you watch one of these videos, it's going to look like I just immediately knew what to do. And that is a complete mischaracterization of what happens. If I'm working on a comparison test myself, not as a student, but like as Kyle, and I'm actually working through this, I sometimes struggle to know exactly what manipulations I want to make. I might have to try 4 or 5 different things. But I know what the goal is. The goal is that I want to create something else on the other side that I know what to do with. Getting something like a p-series or something geometric or a harmonic or like something over there maybe I can do another test on, like an integral test. Something that's over there that's easy to integrate would be good. And if I can get to any of those things, I might be happy because then at least I can try to check to see what's happening with that bigger or smaller function, and then check to see what's going to happen when I try to assess the inequality sign. Okay. All right, well, we'll pause there. Try to, again, go to the worksheet, start to begin to practice this, and we'll take a look at the limit comparison test in the next video.